Hello everyone. Today we are going to write our first program and upload our program to the Siemens PLC. So for doing that we use the ladder logic. So before I start to show how you could do programming in TIA portal, which is the Siemens software, so we need to actually a little understand about the ladder logic that we are going to use. So for doing that, so there is actually some basic concept that you need to know. Let us start with the basic type of the coils and contacts. So in the ladder logic, we use two different contacts, most popular one. So the first one is normally open contact, which use the sample that you see. So it is clear from the name if you have 0 on your input in contactor. So that means if this is 0, so this input is 0, this contact is open. Whenever you have 1 or 24 volt, it's going to be closed. So consider these contacts as a switch, so which actually one input. So whenever this input is 0, so the switch is open. So whenever this input is 1, this switch is closed. So that means whenever it's closed, it's connect this side to the other side that you have. So in the other side, you have the symbol, which is the normally closed contact. Again, this is the switch. So this is the one side of the switch. This is the other side of the switch. And it has the third pin, which is the input. So if this input is 0, so this switch is closed. So whenever this input is 1, this switch is open. So that's the reason it's got the name. It's normally closed. So that means whenever this input is 0, this is closed. Whenever input is 1, it is actually open. So this is exactly opposite of these normally open, which is this is input 0, this is open. Input 1, it's actually closed. So here is opposite. So the input is 0, it's closed. So input is 1, is open. So the other actually component or sample that we use in the ladder logic is the sample that you see. It is the coil. So it is simple. So it could be any output that you have. So whatever you have here as a power. So if here you have the power on the left side of the coil, it's actually turned on the output. So if there is no power, it should be actually off. So that means technically this is the output, which is could be on and off. If here you have the power, it is on. If it's actually no power here, it is actually off. So for today, we use actually two simple program with using the ladder logic. So you see these two, actually the ladder logic that we are going to implement, which is a very simple program. So a few basics about the ladder logic. So here I'm going to mention to that. So usually in the ladder logic, the power usually is of the top of the drawing. So that means here you have the power, and this power, the hot or power rail usually go down the left. So that means here you have the power all the left side, and these power go from left to right. In other words, you could say the neutral rail usually going down from the right side. In other words, here in the left side you have the power, and this power usually move from left to right. So this is actually first things you need to consider. So the contacts that you have, usually they are the input. So here you see here we have these two contacts, which these are our input, and this input usually is on the left. So see these two contact is on the left. So the coil or output usually is on the right side. So as you can see here, this coil here is on the right side. And as I mentioned before, usually the power flowing from left to right side. And usually you could extend your ladder logic, and if you want to do that, so that means somehow I could connect these two, but I didn't that here. We are going to separately run these two ladder logic in our Siemens PLC, but technically you could actually do that too if you want. So in other words, you could say in the ladder logic, you work from top to bottom, okay? So based off these introduction, let's see what exactly the meaning of these ladder logic that you have. So this is a power you have. It comes to your contact. This contact is normally open. So that means if this contact is normally open, if the input is 0, so this is open and this coil or output is 0, it is off. So if I turn on these output of or input of these normally open contacts, so definitely should be close the switch and you should have one here or turn on the coil. So this is exactly the difference of that. If the input of these contact is 0, this is normally closed. So whenever this input of this is 0, because it is closed, this is on. And whenever the input of this is 1, it is open and it should be off, okay? So I just summarize that again. So I want to have these simple ladder logic. So definitely I need to have two input. So one for this, one for this. So whenever this input is 1, because this is normally closed, if the input of this contactor is 0, this is normally open, this should be off. And whenever this input of this contactor is 1, this is closed and it should be on. So here is exactly the opposite of that. If the input of this contactor is 0, this is on because this is normally closed. So that means this input is 0, this is closed. So this should be on. And if the input of these normally closed contactor is if it's 0, it is actually closed. This is on. If this is 1, so it should be open and should be off. So you exactly see that in the software, because software has one section you could simulate that exactly. You could see how it should be work. So just for now, just remember the simple ladder logic and how it works. If I summarize that, we have two different type of the contacts and the one coil. So normally open, if this input is 0, it is open. If that's 1 is closed. Normally closed, if its input is 0, it's closed. If input is 1, it's open. So these two contacts, they are usually the relay or conductor, right? So usually the contactor or relay has one third pin, which you could actually close or open that with giving 0, 1 to that input that you have. This is actually exactly the same thing. The coil is output, it just could be the normal output that you have. If you put here the power, it is on. If you have no power, it is off. So two simple logic with using the normally open and close. So if the input of these contact is 0, because this is a normally open, so 0 is it could is open, so that means it should be off. If you give 1, this close that, this is on. So here if you give the this is normally closed. If you have 0 in the input of these contact, it should be, this is normally closed, right? It should be on. So if it is 1, it should be open and it should be off. So we are going to see that in the software.